imaginary numbers are and why they're used, but if you don't, you should go back and watch my other video on simplifying imaginary numbers, or you should just go learn what they are, because otherwise this would be pretty hard. But if you knew or you do know what they are, let's do this in red. You know that I is the symbol for the square root of -1, because you can't do the square root of a negative number, but we do want to work with those values, so we make it an imaginary number. So I stands for that. But we always need to remember this value, so then we can use it for adding, subtracting, multiplying, and raising to the power, which is exactly what we're doing today. So if we switch back to black, if you do I squared, well, I squared is the same thing as that square root of -1 squared, and that square root and the squared cancel out, so you just get -1. So this value is equal to this value, and you need to keep that in mind when you come to multiplying, especially imaginary numbers, because that can be really helpful in simplifying them. But if you remember this original value of I is equal to square root of -1, then that's pretty easy. So let's get rid of that and do some practice problems with addition and subtraction. If we start with a simple one, 4i plus 7i, you just treat I like a variable, right? So 7x plus 4x is the same thing as 7i plus 4i. The inherent value of it, because you're multiplying them by the square root of -1, you technically know what that is, whereas with a variable you don't know what the value is. But you can treat it like a variable when you're doing mathematical equations like this. So 4 plus 7 is 11. So your final answer is 11i. You don't need to take that I and put it back into square root of -1. It just makes it more complicated, and the reason we have that I is to be a stand-in for that value. So let's do something a little more complicated. -10i plus -40i plus 8i. So you combine like terms. So since you have an I with this -10 and an I with this 8, you get -10 plus 8. Let's actually write that here. -10 plus 8, or -10i, sorry, plus 8i. Oh, let's make this 40, an actual 40, not a 40i. So you have -10i plus -40 plus 8i, sorry. And you move the like terms over, so you have -10i plus 8i minus 40. So -10 plus 8 is -2i minus 40. Now the convention for these is to write it in formula a plus bi. So whatever value you have with the imaginary number, you write that last. So we can just reorganize and flip this to -40 minus 2i. That's your answer. Let's do another one similar to that. -8 minus 6 plus 30i. Again, you combine like terms, so -8 minus 6 is -14, and then you distribute that negative to this positive 30i, so you get -30i. That's already in our convention, so that's our answer. Let's do something, let's distribute a negative, so -4 times 13 plus 5i. So that's the same thing as -4 times 13 plus -4 times 5i. So -4 times, oh, this is 13, not 15, sorry. I wrote 13 up there. 4 times 13 is 52, so you get -52 plus, let's keep the parentheses, -4 times 5 is -20i. You can get rid of that positive there, so you get -52 minus 20i. And that's your answer for this one. Let's do one where you multiply with I on the outside. 2i times 4 minus 7i. So you distribute that 2i in, so you get 2i times 4 minus 2i times 7i. So when you do that, you get 8i minus, well, 2 times, let's do that actually, 2 times 7 times I. So you get 8i minus 2 times 7 is 14, and I times I is I squared. Well, what do we know about I squared? Well, if you take the square root of -1 and square that, then you just end up with -1. So 8i minus 14 times, oh, that moved, times, I was not expecting that to move, times -1. Then you get 8i minus -14. So those negatives cancel out, and then you get 8i plus 14. But you want it in convention, so it's 14 plus 8i. And that's your final answer there. Let's move this back to where it's supposed to be and get rid of this. Let's get rid of everything and do a slightly more difficult problem. Give me a second while I erase everything, but let's try something where you have to do almost like a quadratic. Well, not really like a quadratic, but something where you have to multiply both a normal value and an imaginary value. Let's do 2 plus 4i, that's a weird looking 4, plus 4i times 5 plus I. Well, if we multiply that out, you get FOIL, so 2 times 5 plus 2 times I. If you can see, I'm doing 2 times 5, then 2 times I, going in that order, plus 4i times 5. It's 4i times 5 plus 4i times I. 4i times I. Let's get rid of these weird dots here. So that was only for you guys to see where I was multiplying everything. So 2 times 5 is 10, big whoop, plus 2 times I is 2i, plus 4i times 5. 4 times 5 is 20, so you get 20i. And then 4i times I, so that's where the real math is happening, because you get 4i squared. So 10 plus 2i plus 20i is 22i. Again, you treat it like a variable. Plus 4, and then we know I squared is -1. I'm not going to go through all of that again. And then you get 10 plus 22i, and then 4 times -1 is just -4. But you can take this -4, and 10 minus -4 is 6, plus 22i, and that's already in convention, so we are good to go. And that's it. All you have to do is remember the value again, that it's square root of -1, and all of your math comes from there. You can do everything that you need to do with the I, and then if you are in the scenario that the value changes because you're squaring it or you're cubing it or whatever, then you can do that. But that's all you need to know.